Good morning to all of you. So I am here to make a video on the topic which is periodicity of function. Although it is not in our syllabus, but it is a prerequisite to solve the problems of turning moment diagram, where we have seen that the turning moment or the torque varies with the crank rotation as a function, as a periodic function. So we need to know the periodicity of the function. Okay, so periodicity of the function, which means a function is periodic if we have fx plus t is equal to fx. So if a function follows this equation, fx plus t equals fx, then we say that the function is periodic with fundamental period t, with fundamental period t. When we say fundamental period, it means this t has to be the smallest positive value. It cannot be negative. T cannot be negative, and it has to be the smallest positive value. Smallest in the sense, if we say sin x, cos x, they all are periodic, we know, with fundamental period, that is 2 pi. This is known to us. But again, they are also periodic after 4 pi. But we don't say that the periodicity or the periodic of the period of the sin x or cos x is 4 pi. Rather, we say it is 2 pi. Similarly, for tan x and its reverse, that is the reciprocal of tan x is cot x, they are periodic with fundamental period as pi. And likewise, we can also add on, that is cosec x, which is the reciprocal of sin x, and the reciprocal of cos x is sec x. So they are also having the period as fundamental period as 2 pi and pi respectively. Okay. Now we need to know this fundamental period in order to solve the equations of the torque variation with crank. So this is the fundamental period, and when we solve the problems of the torque variation with crank angle rotation, so we follow this expressions and we use this fundamental periods of these functions. Okay. Now one more thing, if we have a function in the form which is fax, if the period of the function fx is t, then the period of the function fax is t, which is the fundamental period upon mod a, right? Because we know that if we have sin 2x, then the period will become, that is 2 pi upon 2, because we are having a as 2. Why mod? Because it may also be given as sin minus 2x. So in that case also the period, the fundamental period will be 2 pi upon mod of minus 2 is 2, so that will be pi. Okay, so these are some of the basic things that we need to keep in mind. And also, if you have a function, that is function fx, in the form of a linear combination of 3 functions or more than that, f1x plus f2x and so on. Let's say we are taking 3 functions to simplify our task, and the fundamental period we have to find for fx. When we know the fundamental period of f1x as t1, t2 and t3, so in this case we know that the period t of fx is given as, it is basically the LCM of this individual periods, right? So this is another important note. And one more thing, that this t1, t2, t3, which are the period of the individual functions, they may be either the linear combinations or they may also be non-linear combinations, but generally we take the case of linear combinations. Because what happens, if we have, let's say we have LCM of, if I need to find out, for example, this is an example, if we have to find the LCM of, let's say we have 2 pi and pi, so this is simply equal to, it is 2 pi. Okay, so we can calculate the LCM if both are rational numbers or both are irrational numbers only. I mean to say, I cannot calculate the LCM of 2 pi and let's say 5, because one is irrational, this is rational. So this is not defined actually. So we have to keep in mind that we will always take the LCM in which the individual period of functions are either all are irrational form or in the rational form. It may also be in the form of rational, in the sense, let's say we have an example that we have to find the period of sine 2x plus cos x. Let us say this is the question, and we have to find out its periodicity. So we know that the period of sine 2x is simply 2 pi upon 2, and its period is 2 pi, and so this becomes pi and 2 pi. So the period is basically the LCM of these two, and that is equal to 2 pi. Now there is a very important check whenever we have this kind of functions and we are finding out the period. So there is a very important check that don't find out LCM directly. It may happen that we may come up with some mistake. Okay, so that particular note we will be discussing in the next video. Okay, so this is just the basics of the first video. We will move that why to check when we are finding the LCM of this individual periods. Okay, so let's move to the next video.